Have you ever wondered about that powerful, predictable rhythm that just runs our lives? You know, the one that has you reaching for a sweater in the fall or planning a beach trip in the summer? I'm talking, of course, about the seasons. And I'm going to bet the real reason they happen is not what you think.
So why? Why do we get these scorching hot summers and then, just a few months later, absolutely freezing winters? Well, the short answer is that our planet gets heated unevenly. And that imbalance is basically the engine that drives all of our weather, creating the winds and the ocean currents in this constant, massive effort to find some balance.
Now, if you ask most people this question, they'll probably tell you, oh, it's simple. We're closer to the sun in the summer and farther away in the winter. And you know what? It makes sense. It feels logical. Hotter when you're closer, colder when you're farther. But that simple explanation is actually a huge misconception. So let's just bust this myth right here, right now. Because when we actually look at the data, at our planet's orbit, the whole story gets turned completely upside down. Okay, check this out, because this is where that whole distance idea just falls apart. In early January, when it's freezing cold in the northern hemisphere, Earth is at its closest point to the sun. We call that perihelion. And then, in the middle of summer, early July, we're at our farthest point. That's aphelion. Kind of wild, right? And we're not talking a small difference here. It's almost 5 million kilometers. And what that means is that planet Earth, as a whole, actually gets about 7% more solar energy in January than it does in July. So if distance were the only thing that mattered, January should be the hottest month of the year for everyone. And we know that's just not true. So we can say it for sure. Distance is not the reason for the seasons. So that brings us to the big question, right? If it's not how close we are to the sun, then what on earth is actually going on? Well, the answer comes down to two other factors that are way more important. And here they are, the two real keys to the seasons: the angle of the sun's rays hitting us and the length of our days. Let's break down exactly what that means.
All right, clue number one is all about the angle of the sunlight. And honestly, the best way to picture this is to think about a flashlight beam. The angle that beam hits a surface changes everything about its intensity.
So think about it. When the sun is high in the sky, like it is in the middle of a summer day, its rays are hitting the ground almost straight on, at a nearly 90-degree angle. It's just like holding a flashlight directly over a table. You get that small, super intense, bright circle. That's concentrated energy, and that means a lot more heat. But in the winter, the sun is way lower in the sky, right? So its rays hit the ground at a really shallow angle. Now, the same amount of energy is spread out over a much larger area. That means every little patch of ground gets less energy, and, you guessed it, that means less heat.
And there's another layer to this, literally, the atmosphere. When the sun is directly overhead, its rays take the shortest possible trip through our atmosphere to reach us. But when the sun is low on the horizon, its light has to travel through way more atmosphere, which gives it more chances to get scattered and weakened before it ever even reaches the ground.
Okay, so clue number two is a little more obvious. It's just the length of the day. A long summer day with, say, 15 hours of sunlight just gives the sun way more time to heat up the ground, the water, and the air. Compare that to a short 9-hour winter day. That's a lot less time for heating and a whole lot more time for cooling off all night long. So we have these two really powerful things happening: the sun's angle and the length of our days. But what's the one thing that's controlling both of them? The entire seasonal dance of our planet comes down to one simple, elegant number.
And this is it, 23.5 degrees. This one number is the secret key. It's the inclination, or the tilt, of our planet's axis. And believe it or not, it dictates everything.
So what is this inclination of the axis? Well, just picture the Earth as a spinning top. But instead of spinning perfectly straight up and down, it's permanently tilted over by 23.5 degrees. It has this constant lean, and that lean changes everything for us.
And here's the really important part. That tilt doesn't wobble around. As Earth makes its year-long trip around the sun, that tilted axis stays pointed in the exact same direction in space, pretty much right at the North Star, Polaris. And that means, for part of the year, the northern hemisphere is tilted toward the sun, and for the other half, it's tilted away.
So this constant tilt, combined with our orbit around the sun, creates 4 very special moments in our year. These are the big markers that define the start of each season: the solstices and the equinoxes. You've got the solstices around June and December. Those are the extremes, summer and winter. And then you have the equinoxes in March and September. Those are the more balanced points in between.
Okay, so on the summer solstice in June, the northern hemisphere is tilted as directly toward the sun as it gets. That means the sun's most powerful vertical rays are hitting the Tropic of Cancer and we get our longest day of the year. Then, 6 months later, for the winter solstice, it's the exact opposite. We're tilted away, the sun's direct rays are way down on the Tropic of Capricorn and we get our shortest day of the year.
So what about the equinoxes, those in-between days? Well, on those days, Earth's tilt is basically sideways to the sun. We aren't leaning toward it or away from it, so the sun's most direct rays shine right on the equator, and as a result, day and night are roughly equal in length all over the entire planet.
That line separating the day side of Earth from the night side is called the circle of illumination, and it's all because of that 23.5-degree tilt that this line doesn't just cut straight through the north and south poles. This is what gives us amazing things like the midnight sun, where places in the Arctic get 24 hours of daylight during the summer.
So when you put it all together, you realize this isn't just some random quirk of our solar system. It's a fundamental process that shapes every single bit of life on our planet.
Okay, so let's recap the real reason for the seasons. One more time. It has absolutely nothing to do with how close we are to the sun. It is all about our planet's 23.5-degree tilt. That tilt is the master switch that controls both the angle of the sun's rays, how concentrated the energy is, and the length of our days, how long we get heated. That's the elegant truth behind our changing world.
And this matters profoundly. This steady tilt on our constant journey around the sun is the very heartbeat of our planet. It dictates the rhythm of our climate, and it dictates the rhythm of life itself. So the next time you feel the seasons change, remember that stubborn 23.5-degree tilt, and just think about how different our world and we would be without it.